Now, prompt engineering is perhaps the most important skill that you should learn in 2025. And inside this prompt engineering masterclass, I'm going to teach you everything you need to know to become pro at writing prompts. To do that, I'm first going to start by setting the scene by going over some basics, and then I'm going to give you a prompting framework that you can follow for writing almost every single prompt. And then I'm going to tell you some best practices. And finally, I'm going to teach you how you can become a pro if you want to take it one step further. And so with that being said, let's get right into it. So if you guys are watching this video, I assume you guys already know what a prompt is, but just in case you don't know what a prompt is just the input message you send over to the large language model. So let's say if you're talking to ChatGPT, you're always going to have this box where you can write something inside it and send that message over to ChatGPT. The message that you actually send over, or the input message, is what we call a prompt. And then the large language model will get that prompt or that input and it will give you an output. So from now on, every time we say prompt, just think the input message you provide the large language model. So it's important to know how large language models actually work. Fundamentally, large language models are just probabilistic models that continuously predict the next word. So to put this in perspective for you, if a large language model wanted to write the sentence, binge drinking may not necessarily kill or even damage brain cells, it doesn't just output this entire sentence in one go. What it actually does is that it continuously predicts the next word until it outputs that sentence. So basically, it first says binge, and then it says, okay, well, the first word is binge. What's the next most likely word? Drinking. Cool. So now it's got binge drinking. And then it says, okay, well, binge drinking, what's the next most likely word? May. Binge drinking may, what's the next most likely word? Not. Binge drinking may not, what's the next most likely word? Necessarily. So just continues by finding the next most likely word and puts it together to eventually form sentences and talk how a human would talk. But if you guys want to get technical, the large language model doesn't actually output words. What it does is it outputs tokens, or it predicts tokens. Now, for the sake of our discussion, you guys can just think of a token as the same as a word, but a token is generally a portion of a word. So on average, a token is 3/4 of a word. But realistically, you can always just think of tokens as words. And so just to touch on this further, as I said, what the large language model is doing is that it's continuously predicting the next word. So if we start from the inner box over here, what's actually happening is the large language model is getting your prompt, which is your input message, and the output that it's created so far to act as an input by which it's predicting what the next word should be. So basically, like we saw before, we had binge, and then the next word was drinking. That's what it predicted. But basically the idea is that if binge is the output that the model has created so far, the model isn't just taking that into consideration. What it's actually doing is it's taking your prompt, which is your input message, plus whatever output it's created so far into consideration before it predicts the next word. So your prompt, which is the input message, plus the output created so far, is together being used as an input to predict what the next word is going to be. And so based off your input prompt and the first word, which was binge, it's predicting that the next word is drinking. And then what happens is it grabs the prompt plus that output, plus the word it just predicted, grabs and now uses all of these as the new input to then predict the next word. And then once it predicts the next word, it grabs that next word, plus the previous word it predicted, plus all the outputs so far, plus the prompt. So everything in terms of your inputs and the model's outputs so far as the new input to then predict what the next word is. And it basically just continuously does this until eventually it finishes, and that's the response the model gives you. So the idea is, it's not just the output that the model's created so far that's deciding what the next word's going to be. It's actually the combination of your prompt or your input message plus whatever output the model's created so far. And so generally the idea is that your input message or your prompt directly affects exactly what you get back from the model, because it's affecting the probabilities, the probability distribution that's determining what word is coming next. And so with this image, what I want to convey to you guys is that the prompt is actually really important in determining what the output is. And if you literally just add one additional word inside the prompt, that is going to change the prediction of this word and this word and this word and so on and so forth, because it's being used to make that prediction. And so literally every word inside your prompt counts. And that's why it's really important to invest a lot of time to learn how to write the perfect prompt so you can get the perfect outputs from the large language model. Moving on, there's one more concept that I want you guys to be familiar with, and that's the idea of a context window. So I'm sure all of you guys have at least once or twice heard someone talking about a context window, but in case you didn't know what a context window actually is, a context window is just the maximum number of tokens in the input plus the output within one run of the model. So I'm going to say that again. The context window is the maximum number of tokens of the input plus output within one run of the model. So what I basically mean is if you write a prompt once, the maximum number of tokens or words that the model can have within your input and the output that it creates for that specific input within that one run or one execution of the model is what we call context window. So to put this in perspective for you, let's say if a model has a context window of 300,000 tokens, and the input prompt that you write is 200,000 tokens long, meaning the input or the prompt you wrote is really, really long. Then if the output that the model wants to create is 150,000 tokens long, once the model creates 100,000 tokens of output, what will happen is that it will reach the context window limit, meaning it's already got 200,000 inside the prompt and 100,000 in output. So what it'll do is it'll stop there. It wouldn't be able to create more tokens inside the output because it will reach its limit. And so even if the model actually wanted to output an extra 50,000, it can't. So it'll just stop there and it'll break the sentence. And that's the idea of a context window. It's basically just how many tokens can the model remember within one execution in terms of inputs and outputs. And this is especially very relevant for building agentic systems because you want the model to be able to remember what it did in the previous steps as it's trying to execute a new step. And so if you end up having problems where the model has to run a very long bunch of steps, so it's very long time horizon in terms of the problem itself, that context actually gets really large. And if that context gets really large and it exceeds the context window, the model won't be able to remember, for example, what happened back here when it's executing this step. And so that's really bad because it's going to get the model to do something wrong. And so that's why one of the most fundamental things in terms of large language model research and what we're trying to push for is to have models with larger context windows. So right now, as I'm recording this video, the best models that we have 1 million context window. Meaning you can write 1 million tokens inside the input plus the output that the model gives you within one run, which is a lot. It's basically around 750,000 words, which is obviously a massive number of words. But we're pushing this, and even Sam Altman said that in the future, we might have models that have 1 trillion context window. Now, won't that be insane? But getting back to prompt engineering, there's one mindset that you guys have to have in order to write good prompts, and it's extremely important. You have to always remember when you're writing a prompt that a large language model can't read your mind. A large language model will only know what you tell it. So if you're giving the large language model a task, you should always tell it everything it needs to know. So you have to always give it all the context relevant in order to complete that task. You have to treat the large language model like a blank canvas. And this is the biggest mistake that people make. People don't give the large language model all the information required to complete that task, and they expect it to give them a very good output. But obviously an LLM can't read your mind. It doesn't know the background information, and so it's your responsibility to make sure inside the prompt that you're giving it all that information by telling it everything it needs to know. How I like to think of it is when I'm writing a prompt, I always think if I were to tell my friend to complete this task and he didn't know anything about what I was talking about, what information would I need to provide him? So then I'll try and put all that information inside the prompt. Now, just one thing within this analogy is that you don't have to explain the technical concepts to the LLM, because the LLM, for example, already knows what an AI agent is. It already knows what an SEO optimized blog post is. So you don't have to give it that technical info, but you definitely do need to give it the background info and the specifics of exactly what you want the output to be like. And we'll get through everything in just a moment. But one thing I want you guys to definitely remember is that your mindset should always be that I need to tell the model everything it needs to know because it can't read my mind. Now, an example of this is writing a prompt to the large language model saying, Joseph messaged me again today. What should I do? The large language model is going to be like, who the hell is Joseph? Like, what do you mean? How am I going to advise you on what you should do if you haven't even told me who Joseph is? You just said Joseph messaged me again today. This guy might be your best friend. He might be a hater. He might be your colleague. He might be your boss. You didn't tell me, so I don't know. So you have to always give it context. So if I wanted to write a prompt like this, I'd say, I don't know, Joseph is my boss and we've had an argument. He called me again today. I don't know what to do, yada, yada, yada. So you'd give it the actual information it needs in order to complete that task. Now, one fine line here that's actually really important is that although you should give the model as much information as it needs, you shouldn't give it unnecessary information. And this balance between giving the model all the info it needs and not giving it too much info where now it's just unnecessary, unrelated information is what's going to make or break your prompt. And it's really important to always think, is this piece of info actually relevant in solving the task? Like if I was telling the model to go and write copy for an advertisement, I wouldn't tell it that the weather today is 24 degrees. It just doesn't make sense. It's unrelated information. It's just going to throw off the model. Now, with that mindset in place, there's actually one really important technical thing that you guys should be aware of. And that's that the accuracy or how good the output you get from a model is inversely related to the length of the prompt. And what I mean here is that the longer your prompt is, meaning the more words you have inside your prompt, the worse the output that the large language model will give you. So I'm just going to let that sink in because that's really important. The more words you have inside your prompt, the worse output the large language model is going to give you. And you guys can see this inside the graph over here, where as the input length is increasing, the accuracy is decreasing, and it's inversely related. Now, going back to the idea that you shouldn't give the model unnecessary information, one of the reasons why you shouldn't give the model unnecessary information is because the more words you have, the less accurate the output's going to be. And so generally, you don't want to just give it too many words. You want to give it just as many words as it needs, because more words, less accuracy. So it's really important to be able to balance how much the model needs to know without giving it too much information. And if we also think back a couple of slides, as I said, every single word inside your prompt is being used in order to make a prediction of what the next word should be. And so when you give the model unnecessary information, you have words inside the prompt that are going to throw the model off and are going to change the prediction of the next word. And so it's generally best practice to not give the model unnecessary information so it doesn't throw off the model when it's making the prediction as to what the next word should actually be. Now, there's one skill when it comes to writing a prompt that's extremely important. Probably the most important skill that you need to learn if you want to write really good prompts. And I call that skill information density. Now, the idea of information density is that inside your prompt, you want to always say the most in the fewest words without sacrificing clarity. This means you want to make the information inside each sentence of the prompt as dense as possible. So I'm just going to say this one more time because it's really important. You want to say the most in the fewest words without sacrificing clarity. And if you simplify this, what I'm basically saying is you should always remove the fluff inside your prompt. So I can give you an example to solidify this in your mind. A fluffy prompt, so a prompt that's not information dense, could be something like this one. Hi ChatGPT, I have this blog post and I want to summarize it. It's quite long and I want to send a shorter version to people who read my newsletter. They are busy professionals, so I'd like it to be short and to the point. Could you help me create a summary that kind of captures the main points and maybe makes it easier for them to understand without needing to read the whole thing? Please make sure it's good. That's a really, really bad prompt because this very long prompt could literally just be written in these two sentences. Summarize this blog post in 3 bullet points for busy professionals. Focus on key insights and actionable takeaways. So it literally says the same thing in way less words. And so the information in each of these sentences is much more dense than it is in this really fluffy sentence. And generally you'll find that when you first write a prompt, you'll end up making it really fluffy because you're writing it as you're thinking. And this left prompt over here is basically exactly that. The person is still thinking as they're writing. So it's repeating information, it's out of order. It doesn't really make that much sense in terms of its flow. And that's why after you always write the first iteration of your prompt, you should come back and then try and make it information dense by reducing the fluff and, in a way, saying the same thing in less words without sacrificing clarity. And the without sacrificing clarity point is really important because you can technically just keep making it more concise and more concise and more concise and put it in less and less and less words. But at some point, you'll actually start taking meaning away from the prompt and it wouldn't really make sense. And so as much as information density is important, you don't want to sacrifice clarity. So now you guys have an understanding of the two really important things about prompt engineering. And that's why I wanted to front load them because they're super important. First one, the idea of information density. You want to make sure your prompt is as dense as possible by saying the most in the least words without sacrificing clarity. And the second one is that you should always tell the large language model everything it needs to know without telling it too much, because the large language model can't actually read your mind. So these two are really important. Always keep them at the back of your mind whenever you're writing a prompt. So now, just before I get into giving you guys the framework you should use to write prompts, I want to quickly tell you one truth. And that's that every model is different. So the newer generation of models, when they're released, usually the large language model provider actually releases documentation, which inside it gives you best practices in terms of prompting that specific model. And so although in the next couple of slides, I'll give you guys a framework you can use to write really good prompts, if you really want to take it next level, you probably should still look at exactly which model you're using and what best practices they provided in addition to the framework that I'm providing with the best practices. So just keep that in mind. And if you guys really want to become a pro at using any of these models, just read their specific best practices as well. But the framework that I'm about to give you will still take you 95% of the way there, if not 99% of the way there. And so with that being said, let's get into the framework. So the framework is this. Fundamentally, a great prompt has a combination of these 8 components: task, context, role, desired output, audience, tone, specific instructions, and examples. Now, it wouldn't always have all 8 of them, but it usually has a combination of them. And I'm going to get through each of them one by one. And I'm going to give you guys examples so you understand exactly what each of these components actually mean. So the first component, which I believe it should be inside every single prompt, is what we call task. Now, the task is the part of the prompt where you're telling the model to actually do something. Usually a task is a sentence that has an action verb, meaning it's a verb that tells the model to act or do something. So for example, the prompt, write a tweet about the importance of trees. Well, in that prompt, you're actually telling the model to do something. You're telling it to write a tweet about the importance of trees. And the action verb there is the word write. And so generally there's a bunch of action verbs you will use, and these are the main ones. You got act, analyze, categorize, classify, contrast, compare, create, describe, define, evaluate, extract, find, generate, identify, list, measure, organize, pass, pick, predict, provide, rank, recommend, return, retrieve, rewrite, select, show, sort, summarize, translate, and write. I know you weren't expecting me to go through every single one of them, but I did. These are the action verbs that you will generally use when you want to tell the model to do something. And the reason why I say tasks should probably be inside every single prompt you send to the model is because if you don't want to tell the model to do something, you're probably not going to sit there and talk to it. We're not still at that point where people have made best friends with ChatGPT and they want to just talk to it about their lives. Later on, you might just send a prompt to the model to say, I went for a walk today. And then the model will say, oh, that's awesome. You went for a walk. Like, how was your walk? Who'd you see? What did you do? You're not still friends with ChatGPT, so you're not making statements. You still want to usually tell it to do something if you're talking to it. You want it to summarize some text. You want it to write a blog post. So you want it to translate something for you. You want it to make a prediction or categorize something or classify it or whatever it's going to be. So task, super important. Just make sure inside the prompt that you write, you always actually have a sentence where you're telling the model to directly do something with giving it an action verb. Now, the next component, which I believe is equally as important as the task, is the idea of context. Now, context is the part of the prompt where you give the model background information to explain the scenario at hand. So I can give you an example of this, and this will really help in understanding it fully. So an example of a prompt without context is to say to the model, write a reply to a customer complaint. You're telling the model to write a reply to the customer complaint. So actually, let's try and send this through to the model together and see what the model responds. So I've just pasted in to GPT-4o. And as you can see, the model says, sure, here's a professional, empathetic example of a reply to a customer complaint. Thank you for reaching out. I'm truly sorry about your experience. We understand how frustrating this must have been, and we want to make it right. So as you can see, the model is doing its best to actually write a reply to a customer complaint, but because it doesn't know what that customer complaint was about, the answer that it gives me is really generic, and I wouldn't use it. Now, an idea of the same prompt with context is telling the model, first, you work for a friendly customer first e-commerce brand. Then you say a customer received a damaged product and is very upset. And then you say write a reply to the customer complaint. So what you've done is you first told the model exactly what the scenario at hand is. So you say you work for a friendly customer first e-commerce brand, and then you say that a customer received a damaged product and is very upset. So the reason the customer is upset and they've complained is that they've received a damaged product. And so now if I were to grab this and put it inside ChatGPT, as you can see, the output that I get is now specific to the prompt that I've sent. So it's less generic. It's saying, I'm really sorry to hear that your order arrived damaged. So it's referring to exactly what I said in the context, saying a customer received a damaged product. So that already is a much better reply that I can actually use to send off to our customer. So always remember that you have to give the model context. And this goes back to the idea that I said the model can't read your mind, and you should always give it information so it knows how to handle that task. Now, an example of how context can change the meaning of words is this one here. Bark could mean a dog barking. Bark could also mean the bark of a tree. And the way you would know which one of these barks you're talking about would depend on the sentence that they come in, which gives it context. Same sort of deal with large language models. You want to give it context so it knows exactly what you're talking about. So till now, in the main components of a great prompt, we've talked about the top two components, task and context. And these two I would recommend to have in every single prompt. Now, the next one is what we call role or persona. So when you have a task that's domain specific, meaning it requires domain expertise in a specific profession, then you want to tell the model to act as a professional in that domain. So for example, if you want the model to write an SEO optimized blog post for you, it's really helpful if you start the prompt by saying you are a SEO expert. So you're giving it a role within that specific domain. And the reason why this works really well is because it allows the model to use more expertise within that specific domain, which will then lead to the model giving you more sophisticated outputs. And so if you ever have a task that's, for example, accounting related or legal related or finance related or marketing related or whatever it is, tell the model that it's a professional in that specific niche or that vertical. And the outputs that you get are going to be better. And not only the actual expertise are going to be better, but the model often also adjusts its voice and style, basically how it sounds and how it writes to that specific domain. Now, the next key component of a great prompt is the desired output. So inside this section of the prompt, you're telling the model what a great answer looks like. So you're basically telling the model what you'd need the output to look like in order for it to be the output that you desire. And so inside defining the desired output, there's generally 4 components or 4 things that you may want to address. The first one is defining the actual output format. So you're telling the model what format you expect the output to be in. So for example, if you want the model to create an email, tell it to output as an email. And if you say that, the model is going to give you a response that says, hey, XYZ person, hope this email finds you well. And then it's going to write an entire email. And at the very end, it's going to give a signature saying kind regards, Kia, right? So it's going to write it in the format that you requested inside the prompt. If you wanted to create a LinkedIn post, you should say that. If you wanted to create a blog article, you should say that, because then the output that it gives you is going to have H1 headers and H2 headers and dot points and all that sort of stuff that you see inside blog posts. If you wanted to give you a JSON file, well, tell it to give you a JSON file. If you wanted to give you a HTML file, then tell it to give you a HTML file. So defining the output format is extremely important. Now, the next one is defining the output content, which is basically just telling the model what you're expecting to be inside the output from a content perspective. For example, you want to say the output must include this, and this. So if I wanted to, let's say, send an email to my boss and I wanted to say, I'm not feeling well today, so I can't come to work. Well, then inside the prompt, I'll say the output or the email must include a section where I tell my boss that I can't come to work because I'm not feeling great. And that's a section you put inside the desired output because you're telling the model what you want to be included inside the output. Now, the next part of the desired output is where you define the actual structure of the output. And this wouldn't really apply to every single prompt that you write, but sometimes you want the output to follow a specific structure. So you want it to, for example, have a H1 header at the top, and then have a H2 header underneath, and then have a bunch of dot points, and then have a summary section, and then have a conclusion, and then have a FAQ at the bottom. So if you want every single response to look like this, well then give the model this as the structure that you want it to follow when it's creating its outputs. And then when it does end up creating its output, it will literally make sure it has all of these sections inside the output. And the final thing that you can define inside the desired output is the length of the output. So you can tell the model to output a very long blog post or a very short tweet. Or you can say for it to be 400 words long or only 150 characters long. Now, the limitation of these models is that they can't necessarily get the number of words exactly to the point right in terms of what you request. So when you say 400 words, you might get some outputs that are 500, maybe some that are even 600, and some that are 300 or less. So kind of be near the number of words you requested, but it probably wouldn't get it exactly accurate. But nonetheless, it still is beneficial to define the length of the output you want, because although, as I said, it won't get it to the dot, it will still get it around that point. And so fundamentally, as I said, when you want to define the desired output, give it a format, give it instruction as to what the content inside it should be, give it a structure, and define the length of the output. And an example of this without desired output is a prompt that I can send to the model saying, give tips for staying productive while working from home. So I'm just going to copy this and paste it in. As you can see, the model says, here are 5 tips for staying productive while working from home. It's not a bad response, but let's say I only wanted to receive only 3 bullet points, nothing else. What I can technically do is I can give it this prompt instead. I can say, write tips for staying productive while working from home, and that my desired output is that I want 3 bullet points, short and actionable, and I want it to not output anything else. So if I send this through now, as you can see, the output that I get is just going to be the 3 bullet points. It's going to be nice and concise and actionable, and it's not outputted anything else. So no analysis or thinking or fluff around it. And so if you define exactly what your desired output is, it's more than likely that the model is actually going to give you exactly what you requested. So desired output is generally really, really important. So now we've done half of the components. We've talked about task and context, which, as I said, have to be in almost every single prompt. We've talked about role, which is more for domain specific prompts. Then we've talked about desired output, which is for scenarios where you want the output to follow a specific format. Now, the next 4 is what we're going to get into in just a moment. The first one is what we call audience. In this section of the prompt, you want to tell the model who will actually be reading its output. You're basically telling it who the audience for its output is actually going to be. So when you tell the model who the audience for the output is going to be, the model actually kind of changes its response to tailor to that specific audience. And when you want to define the audience, there's 2 things or 3 things that you should think of. The first one is the demographic and interests of that audience. So for example, if the output is being read by busy executives, you can say that the reader is a busy executive interested in AI. So that's who it is. It's a busy executive and they're interested in AI. So if you were to write that, likely because the model knows that they're busy, it's not going to write really long outputs where it's got so much fluff the person has to sit down and read for 10 hours. It's probably going to make it more actionable, more concise. And because they have an interest in AI, it's probably going to relate it to AI at some point to get that specific person interested in its output. Now, the second thing that you should define, which is really, really important, is the reading level of the output the model actually creates. And you do this by saying use a year whatever reading level. So use a year 2 reading level or 3 reading level or 5 or 10 or 12 or high school or PhD or whatever it's going to be. And I generally like to recommend using a year 2 to year 3 to maximum year 5 reading level for most marketing use cases, because generally in marketing, it's known that the simpler your text is to understand, the more people will resonate with it. And so generally a very small number in terms of the reading level will generate better outputs for marketing use cases. And this reading level basically just equates to how simple or how complex the language used inside the output of the model is actually going to be. So an example of this is I can tell the model to write a blog post about trees. This is if I didn't want to give it a specific audience. So it's going to say why trees matter, nature's silent superheroes, trees are some of the most important living things on earth, they clean the air, yada, yada, yada. So it's just nice blog post about trees. Now, if I wanted to give it a specific audience by defining the demographic and also their interest and also their reading level, I could say something like write a blog post about trees, use a year 2 reading level, and the readers are tree enthusiasts that also really like technology. So if I send this through, as you can see, the output's going to say, hello, tree friends. Do you love trees and computers? Then you're in the right place. So as you can see straight away, it's using a year 2 reading level because it's saying, hello, tree friends. Well, obviously that's a year 2 person's type of language. And then it's saying, do you love trees and computers? The reason why it's mentioning computers is because I said the audience are tree enthusiasts, but they also like technology. So it's trying to refer to their interests. And so generally for copywriting tasks or tasks where you're telling the model to actually write something for you, if it's a blog post or a LinkedIn post or a newsletter or whatever it's going to be, it's really good if you define the actual audience for that specific piece of writing. And the next component of a great prompt is what we call tone. So I'm sure all of you guys already know what tone actually is, but the tone of text is basically, in simple terms, just the vibe of that text. It defines the emotion that the reader will get when they read that text. So for example, do you want it to use an exciting or engaging tone or whatever it's going to be? The reason this is really important is that in copywriting tasks, you want to always try and convey a certain emotion inside your text. That's how you get people engaged. That's how you get people to continue reading. And the tone section of the actual prompt is the part of the prompt where we define exactly what emotion we're trying to convey inside the reader. Now, generally, if you guys are like me and you don't actually know what all the tones are called, you can work backwards from the emotions. So instead of having to figure out what tone generates fear, you can say, I want 3 tones that generate the emotion fear. And the model will give you the 3 tones that generate the emotion fear. And then you can just choose the one that you think is best suited and use that one inside your prompt. Now, an example of this is write a blog post about the future of AI. That's no tone. With the tone, it says write a blog post about the future of AI, which is what we just saw. And then it's going to say keep the tone casual and humorous. And if we say that, what the model is going to do is that it's going to make sure it's cracking jokes and keeping it really casual in the output that it provides. So again, in writing tasks, adding a tone to the prompt is really helpful. Now, just to reiterate, audience and tone are 2 components of a great prompt that are really relevant when you're telling the model to write something for you. So any sort of copywriting task, super relevant. But you probably wouldn't tell the model to use a certain tone if you want it to solve a math problem or write a bunch of code for you, because it doesn't really make sense. So mainly use this just for tasks where the actual output or the copy that the model creates is something you're distributing to other people. Now, the next component of a great prompt is what we call specific instructions. So in this section, you're giving the model a bunch of rules that it should follow when it gives you the output. So just imagine, what do you want the model to always abide by? What things do you want to make clear to the model in terms of maybe how it should think, how it should infer, and how it should create the output for you? And you'd put that inside a bunch of dot points within a section called specific instructions. You might be thinking by now that desired output, tone, and audience kind of are giving the model specific instructions, and that's completely correct. So these sections also are subsections within specific instructions. But if you ever have any additional rules that you can't give the model inside desired output, tone, or audience because it doesn't really make sense for it to be inside those sections, you can give it inside the specific instructions section. And this is especially relevant for building AI agents because inside the specific instructions section, you tell the model the process you want it to follow when it handles a certain scenario. So for example, if you're building a personal assistant, you might say every single time someone asks you to reply to an email, first go and check if there is an email about that person, then find that email, then think of a reply, then send the reply. So you tell it the steps that it should follow in order to handle that specific thing. Now that is giving the model specific instructions. And so an example of giving a model specific instructions when you want to tell the model to write a blog post about trees is you can say, use plain language with no jargon, don't repeat information, and keep it clear and concise with no fluff. So you're giving it additional rules that it should follow when it gives you the output. Now, as you guys can see on the left side, as a good exercise, we have 3 things inside the prompt. So the role says you are an SEO expert. The context says you write SEO optimized blogs that rank well in Google. And the task says write a blog post about trees. So that's role, context, and task. So you see how easy it is to include these sections inside a prompt? The outputs that you're going to get when you include all of these, or the correct combination of these for your specific use case, is going to be really good. As long as you ensure you're still keeping the information dense and you're telling the model everything it needs to know without giving it too much info of things that it doesn't need to know. Now, the next component of a prompt that's extremely important is examples. So in this section of the prompt, you're giving the model an example or a couple of examples of input and output pairs. So you're saying for this specific input or this version of the task, this is a great output, or this is a great response that you can give me. So that could be example number 1. And then you can have example number 2 with another input and output pair. And then you can have example number 3 with another input an output pair. And the idea is that when you give the model examples, you actually stop the model from having to guess what output it's meant to give you. Because if you think about it, when you write a prompt, even if we define all the desired output and all the other sections inside the prompt, the model has to think, okay, well, based off these instructions, how can I action these by converting the prompt into the correct output? So the model is guessing what the output should be based off the prompt that you gave it, which is just a bunch of instructions or a bunch of information. Now, when you give the model an example of a good input and output pair, you tell the model, this is, or this output is exactly how all of these instructions should be incorporated. So this is what I'm expecting from you in the output that you give me. And so you guys might have heard of the idea of zero-shot prompting and one-shot prompting and few-shot prompting. The idea is basically just talking about how many examples are inside the prompt. If the prompt has 0 examples or no examples, we call that zero-shot prompting. That's just a prompt with no examples, just a bunch of instructions, desired output, role, context, all the other stuff. If it has 1 example, 1 input-output pair, then that's what we call one-shot prompting, which is really good. And then if we want to go above and beyond, and we want to include multiple examples, as I said, input-output pair 1, input-output pair 2, and so on and so forth, then that's what we call few-shot prompting. And the idea is when you give the model just 1 example, so you have one-shot prompting, the model will try and mimic that specific output when it creates your output. But when you give the model multiple examples, what it actually ends up doing is that it ends up trying to identify patterns within these outputs, which lead to more sophisticated results. So it doesn't really have to try and mimic this specific output. It tries and understand that relationship and then responds based off that relationship. So I hope that makes sense because it's really important. So an example of a zero-shot prompt or a prompt that has no input-output pairs or no examples inside it is this. I can tell the model to guess this person's age and height and then give it a statement from that person. So let me show you what I mean by this example. I can tell the model to guess this person's age and height. Just got back from high school and my mom says I can't play Xbox until I finish homework. So I'm assuming that this person is really young. So they're probably a kid. Their age is, like 11 to 14 year olds makes sense. And their height, it's saying for that age range, the average height might be between 4'10" and 5'6". So as you guys can see, the model is giving me its analysis first, and then it's giving me 2 dot points, one with age, one with height, and it's talking about height in terms of feet and centimeters, and then it has a little sentence at the end here as well. Now, what I can do is I can give it the same example, but this time I can actually give it an example input and output pair. So as you guys can see inside this input example, I'm saying, my boss is so mean, he gave me more work to do today. That was the input, which is the same as this expression, right? But just a different example of it. And then the output that I said is good for this input is if the model were to say to me, age 29, height tall. So just 2 dot points, one with age and a number, and one with height and short, tall, or let's say medium height. And so if I send this through to the model now, it will give me an output for this expression, which is just got back from work. My mom says I can't play Xbox until I finish my homework in this format. So as we send this through now, we see that the model responds with age 11 and height short. So it just gave me the 2 dot points, age with number and height with short, which is exactly what we said we like as an output. And so as I said, the whole idea of examples is just to summarize everything and make it practical in terms of what the prompt means for an output that should be created. So you're removing the guesswork from translating the prompt to the output for the model. Now, generally one thing to consider is, as I said, the larger your prompt is, or the more number of words you have inside your prompt, the worse the output that you're going to get from the actual model. The problem with this is, in scenarios where the example is really long, you can't give the model multiple examples. Let's say, for example, you want to tell the model to write an SEO blog post for you. Now, in terms of giving it examples, you might give it examples of SEO blog posts that you've written in the past. But if each blog post is 5,000 words and you want to give it 3 examples, well, that's already 15,000 words that you're adding to your prompt. And 15,000 words inside your prompt is 100% going to skew the output that you get, and it's going to reduce the output quality. And so generally, the longer the examples are, or the more lengthy the examples are, the less examples you want to give inside the actual prompt. So although generally more examples means better outputs, but because more examples means a larger prompt, it may actually result in worse outputs. So it's really important to just think how long the actual example is, and based off that, how many examples you think you can give before you start deteriorating the model's outputs. And so if you guys are familiar with the whole idea of fine-tuning models, this is why they fine-tune models. Because technically, when they make the large language models, when they pre-train these big large language models, at the start, they're just trained on the entire internet. And they're not trained to give an answer to a question. And so when you have the first pre-trained model and you write a question like, what's the capital of France? It's not just going to respond saying whatever the capital of France actually is. It's going to just continue on based off what it thinks should come after that question, because it's a prediction model. And that's why when AI engineers want to turn these large language models to conversational models, what they do is they give it a whole bunch of input and output examples where the input is a question and the output is the answer to that question. And they give the model a whole bunch of these examples, and eventually the model realizes that, okay, when I get a question, I need to answer that question, not just say what's most related to that question. And they give the model thousands and thousands and thousands of examples, if not millions of examples. And if they were to put that all inside one prompt, obviously that would be a really long prompt and it'll probably exceed the context window by a lot. So they don't put it inside the prompt. What they actually do is they get these input and output examples or these input output pairs, and they train the model on it, or they fine tune the model on it. So it's like giving the model examples so the model knows how to respond. But you want to do it at a very large scale. And in order to do that, you can't put it inside the prompt. So what you actually end up doing is you train the model on it. Hope that makes sense. But that's a really important concept when it comes to building really specialized AI models. So then comes the question of how many shots or how many examples should you include? Well, there's 4 things to consider. Number 1, how complex is the task? The more complex the task, the more examples, the better. Well, what's the quality of the examples? If you think the examples are very clear and they tell the model exactly what it's meant to do with all the nuances, then you don't need to give it multiple examples. But if you think there's multiple different nuances and that example doesn't capture everything, then you'd need to give it multiple examples. What are the capabilities of the model? Like, as these models get better, eventually they'll probably get better at giving responses without needing to specifically have multiple examples to tell it exactly how to translate that prompt into a correct output. But this one, I would say, is less important. And then the last one, as I said, is the length of the example. The longer the example, the less number of examples you give, because you don't want to reduce output quality by increasing prompt size. But generally, I like to say at least include 1 example. If you really want to go above and beyond, 3 to 5 examples in few-shot prompting is really good. Now, if you guys are lazy like me and you can't be bothered to sit down and think about an input and the perfect output for it, well, what you guys can do is once you write the prompt to the model, just do it with no examples at the start, so make it a 0-shot prompt, and then get the model's output. So the model will give you a response, right? Then what you want to do is you want to get that output and fix it up so it's the desired output that you want. So fix up all the things that you didn't like about what the output was and make the perfect output. And then all you have to do is grab this desired output and then grab the input that you had inside the prompt, and that's your input output pair. Does that make sense? So instead of you sit down and think about an input and an output, just send through the input that you have anyway with your prompt without an example. The model will give you an output, grab that output, make it better, and then use that as an input output pair. And then you can do it for another input and another input and another input after that. So this is a hack for the model to give you input output pairs instead of you having to sit down and think of the actual output yourself. For example, when it comes to writing a blog, it would be really annoying and it'll take a long time for me to sit down and write 1,000 blogs if I wanted to fine tune the model. You can technically just get the model to give you 1,000 blogs and just fix them one by one. It will end up taking a lot less time. And 1,000 blogs is obviously exaggerated, but you guys get the point. Get the model to give you an output, fix the output, use it as an input-output pair. And now that was the 8 components of a great prompt. We had task and context, which are really important for every single prompt. We had role and desired output. We had audience and tone, which is really important for writing tasks. And then we had specific instructions and examples, which are really important to take your prompt to the next level. So as I said, you wouldn't use all of these all the time. You just use any combination of them that you think is relevant to the specific task you have in hand. And the way you'd write this as a prompt is you'd have headers using Markdown language. So in Markdown, generally a hashtag means a H1 header, and then 2 hashtags means a H2 header, which is just a subheader, and then 3 hashtags is a H3 header, which is a subheader underneath that, 4 hashtags, and so on and so forth. So the idea of how you want to put these sections inside your prompt is you want to have one hashtag, role and context. So I generally like to combine role and context inside the same section of the prompt. And then you have another hashtag, task, which is telling the model to do a certain thing. And then you have another hashtag, specific instructions. So these three first hashtags were all H1 headers. So they were main components of the actual prompt. As I said, desired output, audience, and tone sit within specific instructions. So I have them as H2 headers underneath specific instructions. So you got specific instructions, desired output, audience, and tone. And then the ones, as I said, that you can't put inside desired output, audience, and tone, you can put it in another H2 header called other rules. And so you'd have text here, text here, text here, text here, text here, and text here. And then you'd have examples. You say, hey, these are a few great examples that you can use when you provide your own output. And you'd put the examples here. And so that is generally the framework or the template or the cheat sheet that you'd use when you're writing a great prompt. Now, just one important concept is that if your prompt ends up getting really long, maybe you have a whole bunch of examples or you have a whole bunch of context or the other rules gets really long or whatever it is, you end up having a prompt that's really, really long. It's best practice for you to reiterate the important points at the end of the prompt again. So at least put the task and any important context and maybe the really important rules at the bottom or end of the prompt without going into excruciating detail like you did up here. You just want to kind of touch on it and mention it again. And the reason why this is relevant is because large language models kind of work like human brain. When you give them really large amounts of text, they tend to remember the first part and last part really well, but they sometimes forget details inside the middle of the prompt. And so the idea is, if you reiterate what's important at the last part, then the model will definitely remember it and it wouldn't forget it. So the first part and last part is the parts that it will most likely remember really well. And in the middle, it might lose some information. So always, if there is anything that's really important in the middle and you don't want it to forget, or if there's anything that's important at the top and you want to reiterate it at the bottom, but don't go into excruciating detail because we don't want to make the prompt even longer because that's going to reduce the quality of the output that you get. And so an example of this could be a prompt like this that says, role and context. You are a professional productivity coach who specializes in helping remote workers build better habits. So that is basically the role. And then it says, you've worked with hundreds of individuals to improve their focus and daily routines. Well, that's a bit of context. It's saying what you've done. And then it's saying the task is to write, that's the action verb, a short tip for staying productive while working from home. So that's the task. And as I said, you had the action verb there that actually told it to do a specific thing. And then we had specific instructions. Underneath that, we had desired output. In desired output, we're telling it what we would like the output to have. It's good to use dot points here as well. So I say a tip written in 2 to 3 short sentences. So that's what I want. And then I want it to be actionable and easy to understand. And then I want it to avoid cliches like just stay focused. So that's the factors that's important to me about the output. Now I could have gone one step further and said, make it 200 words or put it in this specific structure, and always make sure to include this, this, and this. And then the audience is remote workers who struggle with distractions and maintaining work-life balance. And then the tone is an encouraging, practical, and no-nonsense tone. And then in terms of other rules, I have a bunch of dot points like do not use technical jargon, avoid generic and vague advice, keep the language friendly and informal. So that's the other rules. And then I have the actual examples. And actually one important thing here is that the examples don't have an input and output pair. They just are output examples. And the reason for this is that the input or the task is always just going to be to write a short tip for staying productive or working from home. There's no point saying that 2 times you're putting 2 examples or 3 times you're putting 3 examples. You just want to put the example of the output because you're saying that the input is always going to be the same. But I hope that makes sense. But over here, the example that's inside the prompt says set a timer for 25 minutes and focus on just one task. When the timer rings, take a 5-minute break. This is called the Pomodoro technique, and it helps you stay sharp without burning out. So that's a productivity tip, apparently. And then there's another example there as well. And so this specific prompt, I literally told ChatGPT to write for me. I didn't even write this prompt. I just said, these are the sections of a prompt that I think are relevant. Please write a prompt example that I can share that has these specific sections. So ChatGPT can also help in writing pretty good prompts, and I'll get into that in just a moment. Now let's talk about some prompting best practices. The first best practice is to use Markdown when you write your prompt. So Markdown is basically just a markup language which is basically just a way of formatting, meaning you're putting the text in a specific format with headers and subheaders and dot points and bolds and italics and that sort of stuff. The same way you see it in Microsoft Word, but just instead of you seeing the actual output of it, you're coding it in the backend to achieve that specific output. So in Markdown, as I said before, H1 headers will have one hashtag, H2 headers have two hashtags, H3 headers have three hashtags, four hashtags for H4, so on and so forth. And then dot points just have a hyphen and a space. So hyphen, space, whatever is a dot point. Hyphen, space, whatever is a dot point. And then if you want to make something bold, you just put 2 stars on the 2 sides of it. That's generally all I would say you would need to know from Markdown when it comes to writing prompts on ChatGPT. Now, one thing to consider is that specific models also have their specific preferred markup language. Like Claude says they prefer XML. XML is just another markup language that instead of having hashtags and hyphens and asterisks, it has this smaller sign and greater than sign, and then you write whatever the name of that specific section is, and then at the end of that section, you put it again, and you just put a dash, and then you write that specific name again. And that means anything in between this part and this part is related to this specific section name. But generally, I still tend to use Markdown in all of my prompts, even if I end up using Claude, because I do believe that Claude will still operate better with Markdown. It's just if you wanted to operate best, you would use XML. So if you guys are bothered to sit down and learn XML as well, feel free to learn XML. It's really not that hard once you get the point of it, but I would say for most of you, if you just learn Markdown and then incorporate that into all your prompts, you're already going to get really, really great results. Now, the next best practice is probably the most important best practice of all, and it's to always design with simplicity. What I mean is that when you write the prompt, always read the prompt and ask yourself, is this the simplest version of what I'm asking for? Or in other words, is this the simplest way of saying what I'm trying to say? I'm going to say that one more time. Is this the simplest way of saying what I'm trying to say? Now, when you want to assess the simplicity of your prompt, you would look at 4 different factors. The first one is conciseness. Conciseness goes back to the idea of information density. How much fluff is inside your specific prompt? So you want to minimize the fluff as much as possible to make it as concise as possible, meaning you want to have as much meaning as possible in as little words as possible without losing clarity. So conciseness or information density, really important. Then we have clarity, or how clear the prompt is. So inside the prompt, you don't want to make the prompt confusing or contradictory. Contradictory being at the top of the prompt, you might say one thing, and at the bottom of the prompt, you might say the complete opposite thing. Now, when the model is trying to respond to this prompt, it's going to be like, but like at the top, you told me this, and now at the bottom, you're telling me something completely different. So it's not going to know how to respond correctly. So you have to make sure that your prompt is logical and it doesn't contradict itself, and it's not confusing. It's easy to understand. Now, an example of something that's contradictory could be detailed summary. Like summary means make it short, and then detailed means make it long. So detailed summary is kind of contradictory. Now, the third thing you should think about is how easy to follow is this specific prompt. So you want to make sure that your prompt is well thought out, so it actually flows nicely. Like at the first, you say this, and then you say this, and then you say this, and then you say this, and this, and this, and this. You want to make sure that it flows logically. It makes sense for you to say this first, and then say this after, and say this after, and this after. And the only way you can do that is to make sure that your prompt is well thought. Like if I were to just write something as I'm thinking it, it's very likely that I'll have a thought, then I'll have another thought, then I might go back to that thought, and then I might go back to that thought. And it's just like I'm breaking these thoughts, and it wouldn't actually flow naturally and logically. If I were to just talk without thinking and just kind of write down my thoughts as it's coming through. But the idea of making it well thought out is making sure that the flow of what I'm saying actually flows on nicely and each idea picks up from the other idea. So that's really important when it comes to writing a great prompt. And it's also important to make sure that the prompt is easy to understand, meaning you're not using any complex language. There's no point trying to impress ChatGPT by writing really difficult to understand words or putting it in really difficult to understand language. The simpler you can make the actual prompt, the better the outputs you're going to get from the large language model. Now, I've already talked about this last one before, but the idea is you want to give the model just enough info. So as much info as you think it needs to complete the task, having known nothing about the background of that scenario in advance, but not too much info where you're giving it irrelevant information that's going to make the prompt long and actually just going to throw it off by giving it words that it doesn't need to see inside that prompt. So not too much, not too little. And this within itself, as I said, is a skill that you guys will develop as you write more and more prompts. Now, an example of a prompt that's not very well thought out is the one on the left side. It says, I am visiting New York right now and I'd like to hear more about great location. Okay, I am with 2 3-year-old kids. Where should we go during our vacation? It's saying I want to hear more about great locations, and it's saying, where should we go during our vacation? It's got, I'm with 2 3-year-old kids here, and it says I'm visiting New York. It's just the ideas aren't put in a nice logical flow. This could be written with simplicity in these 2 simple sentences, saying act as a travel guide for tourists. So you're giving it the role, as we talked about before. And then it's saying describe great places to visit in New York, Manhattan with a 3-year-old kid. Now, I probably wouldn't use describe, I'd probably use recommend. But the idea is saying recommend great places to visit in New York, Manhattan with a 3-year-old. So you're not saying, I would like to hear more about great locations and then saying, where should we go during our vacation with a bit of information in the middle. You're just making sure that everything actually flows on logically from what you said before. So designing with simplicity, really, really important. Always think, is this the simplest way of saying what I'm trying to say? Is it concise? Is it clear? Is it easy to follow, easy to understand? And does it have just enough info? Not too much, not too little. Super, super important. Now, how I achieve designing with simplicity is that I always just write my thoughts first and then I proofread and fix it. So as I said, it's really hard when you're first writing a text for the first time to make it be really well thought out and flow logically. So what you should generally do is in the first iteration, you should just write everything that comes to your mind, everything that you think is relevant for the model to know, all the sections like role, context, audience, tone, whatever. And then what you want to do is you want to proofread it and fix it to make it better. So then you would come and say, okay, well, this section is probably just fluff. I can remove this. This section probably needs to be at the top there. This section doesn't make sense. I'll remove it. This section probably needs to be down there. And you kind of just adjust the prompt to make it more clear, concise, easy to follow, easy to understand, and with just enough information. So just write the first iteration and then fix it. Now, one thing you could also do is you could use what we call automatic prompt engineering. And it sounds fancy, but basically what it's saying is to just get the AI to write the prompt for you. And the reason why I've mentioned this here is that a good thing you can do is first, you just write your thoughts. So you put down all the information you think that's relevant inside that specific prompt. As I said, all the components that I talked about before. So this is your first iteration. And then what you want to do is you want to give it to AI and you want to say, hey, can you design this with simplicity by making it clear, concise, easy to follow, easy to understand, and remove irrelevant information. And then the model is going to give you a, let's say, better prompt. And then what you want to do is you want to read this prompt again and make sure it's exactly what you want. And then once you've optimized it, then you'll use that as your final prompt. So just to reiterate, you first write down all the information that you can think of. Then you get the AI to improve it. And then you get AI's improved version of that prompt and optimize it again just to make sure, or proofread it again just to make sure it's exactly what you want. And the reason why you don't just start from this step, getting the AI to write the prompt for you straight away, is as I said, the AI doesn't actually know what you want. You have to tell it what you want. So you are the only person that knows all the context, all the background info, all the specific instructions, the desired output. You're the only one that knows what should be inside the prompt. So it always would start with you writing down all the relevant information. And then if you want to improve it, you can use AI. And then to improve that again, you'd proofread it and make sure it's exactly what you want. Because sometimes when you put something inside AI, because AI is a stochastic model and they basically a random model, so they change outputs, it will change certain sections that might now go out of context. Certain things might not make sense anymore, might not actually be true. So you want to check it one more time just to make sure it's all good. And then if it's all good, then you'll send it to the actual AI as the actual prompt you're using. And that is the idea of automatic prompt engineering. And the reason why people say automatic prompt engineering is really good is because people generally say, an AI knows what an AI likes. So generally, AI can prompt itself better than a human can, or at least this is what people say. So automatic prompt engineering is actually a pretty good technique. But I personally tend to write my prompts myself because number one, it gets me better and better at writing prompts every single time I write a really nice detailed prompt. And number two, I do fundamentally believe that I'm the only person that knows how to put this prompt in the perfect words to send it through. I know what's fluff, what's not fluff, what needs to be there, and what each section should look like. And eventually, as you guys do this more and more, you'd end up getting to a point where you feel more comfortable just using your own prompt as opposed to sending it to AI. But having AI help you at the very start is still a good thing to do. And then if you guys do generally think that the AI gives better results, then happy days, you can just use AI always. But just as I said, always write down the first iteration yourself and try and improve your own prompting skills as well. Now, the next best practice is to use instructions over constraints. What this means is instead of telling the model to not do something, you should tell the model to do something instead. So instead of saying, don't do this, say do this. So instead of telling the model, don't be funny, you should say, be serious. So instead of saying a negative sentence like don't do this specific thing, you should just say the opposite positive sentence. And the reason why this is important is that when you tell the model, don't be funny, it will actually end up being funny. And from a technical perspective, the reason for this is that the model actually doesn't think of don't be funny as don't be funny. When it actually goes through greedy decoding and when it's predicting the next word and the next word, the next word after that, it just sees the word funny inside its context. And because it sees the word funny inside its context, it actually thinks that it should be funny in the words that it predicts. It doesn't really see that we said don't be funny right before it. So this was a big fundamental problem with models till now. If you told it to not do something, it will just end up doing that specific thing. And the way you'd overcome this is always try and think, okay, what's the opposite of this thing that I'm telling the model not to do? I'll just tell the model to do that thing instead. So the opposite of being funny is being serious. So instead of saying don't be funny, I'm just saying be serious. And with the foundation of models like GPT-4.1 and now Claude 4 Sonnet, they're actually saying that these models have gotten smart enough to know that when you say don't do this, you mean don't do this. So technically now people say you can have these constraints inside your prompt. I'm still skeptical, and I've heard people say that when they still say don't do this, it ends up doing that thing. So I always recommend think what is the opposite of this thing that I'm telling it not to do, and just tell it to do that instead. Now this might be hard for a lot of cases. A lot of cases it's hard to think what the opposite of a negative thing is. So if you need help, just ask Perplexity or ChatGPT. Be like, what's the opposite of this specific thing? It will tell you what the opposite is and just tell the model to do that. Now the next best practice is actually a really simple one. If you got a bad output from the model, just run it again. You might get a good output this time. Now the idea comes from the fact that if you run a model 10 times with the same prompt, you'll actually get 10 different outputs. And the reason for this is stochastic, or the model is random. So within that prediction of the next word and the next word and the next word after that, there is a certain element of randomness. And so every single time the model gives you an output, it's going to be a different output because the model is actually fundamentally random. So it might still say the same thing, but it'll say it in different words. And the good thing about this is that if you get a bad output from a model, you might be able to run it again and this time get a good output from the model because it thinks about it all over again and it gives you an output all over again. So if you get a bad output, just run it again. Now there's a technique called self-consistency prompting. And the idea behind self-consistency prompting is that if you want to get the best output from the model, what you should do is you should run the model, let's say 10 times, and then see which output it gave most often. And then just use the output that it gave most often as the correct output. So this is especially relevant in classification tasks. Like for example, you're telling the model to classify this piece of text as either category A or category B. And then you run the model 10 times and it will classify it 10 times. It might come back with category A as the classification 8 times and then category B as the classification 2 times. Then you'll know that category A is most likely the correct answer because the model gave that most often. And that's the whole idea of self-consistency prompting. Now, the bad thing about self-consistency prompting is obviously running the model 10 times is going to be very expensive, so it's going to be costly. And it's also going to be very high latency because you're going to have to wait for the model to run 10 times. Latency just means time delay. So it's going to take a long time and it's going to also cost you a lot if you're doing it via the API. Now, also to make self-consistency prompting make more sense, you want to keep the temperature of the model high. And the temperature is basically just this factor that you can control inside the model's behavior that tells the model how creative or how random its outputs should be. And I'll talk about that in a couple of slides. But as I said, if you get a bad output, just run it again. Now, the next best practice is to break down multiple tasks into one task per prompt. So the idea is every time you write a prompt, you should only have one task inside that prompt. So if you one day want the model to solve a problem for you, which has multiple steps or multiple tasks, like task 1, task 2, and task 3, instead of putting them all inside the same prompt, put them in 3 separate prompts and you're likely going to get better results. So to give you an example, you can say to the model in one prompt, summarize this article, which is the first task, first thing you want it to do, translate it to French, the second thing you want to do, and then write a tweet about it. So you can technically put all of these 3 tasks inside the same prompt. The model will likely get confused or it will skip over one of the steps. So you wouldn't do the steps as well as it should. Is for you to say prompt number 1, summarize this article in 3 bullet points. So you write that and you send it through, and then you get an output from the model. The model will give you the summary back. Then, in response to the output of the model, you'll say, cool, now translate the summary into French. Then it will translate the summary into French and give the output back. And then to the French translation, you can say, turn the French translation into a tweet under 280 characters, and it'll give you an output back to that. So instead of me telling the model to do 3 things at once, I'm telling it to do 1 thing, it's going to give me the output, and I'm going to tell it to do the next thing, it's going to give me the output, and I'm going to tell it to do the next thing, and it's going to give me the output of that. So you're chaining the prompts. So nowadays we have what we call reasoning models, and reasoning models are capable of solving multi-step complex problems because they're able to think through a problem step by step. They can actually think. They don't just give you an answer straight away. So with these reasoning models like O3, O4 Mini, and whatever is going to be when you guys are watching this video, these reasoning models can take prompts that are multi-step or multitask. So you can technically put all 3 inside one specific prompt for a reasoning model. But the problem with these reasoning models is that they're often not optimized to do copywriting. They wouldn't do really well with this prompt because you're telling it to summarize an article, translate it to French, and write a tweet about it. Reasoning models are more so used to solve complex problems. Like for example, a math problem or a science problem or a research problem, where it's actually like thinking. So problems like my grandpa's 20 years old, my auntie's 20 years older than her, 5 years ago, my age was blah, 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 what's my son's age? Or whatever it is. Like you get what I'm trying to get at in terms of those types of questions where it's thinking questions. So generally, if you still have like an everyday use case where you just wanted to write something or summarize something and it's multi-step, use a normal non-reasoning conversational model like 4o, 4one, 4Sonnet, all those models, and just separate it into one prompt per task. And if you guys are building out AI systems, you should also do the same thing. So if you're building out an AI workflow, have one AI node do one task, and then pass that info to the second AI node, which does the second task, pass that to the third AI node, and so on and so forth. And so that brings me to this slide that says you should always know which model to use. As I said, fundamentally right now, there's 2 types of models. You got conversational models and you got reasoning models. Reasoning models can think through problems, so they're good for complex multi-step problems. As I said, something like a math problem or a science problem or even a brainstorming problem. Like you got something going on with your business and you want it to think through that problem and give you advice. These complex tasks should be completed by reasoning models. Now, if you have a simple everyday task like writing something or summarizing something or even analyzing something in certain scenarios, it's better to just use conversational models. Now, conversational models, as I said, like GPT-4o, GPT-4.1, Claude 4 Sonnet, and the other models out there that's not thinking models. Reasoning models like O3 Mini, O3, O4 Mini, O4 Mini High, Claude 4 Sonnet Thinking, Grok 3 Thinking, and there's a whole bunch of other models from different providers. So just if the model says it's a thinking model or it's a reasoning model, use it for complex tasks. If it doesn't, use it for everyday tasks, because these reasoning models, they generally also are a lot more expensive because the model will charge you for its thought as well. If it thinks for a longer amount of time, it's also going to charge you more, because when you use an LLM, you pay based off the number of tokens it consumes inside that input and output pair. More tokens inside the input and output, the more it costs you. Less tokens, the less it costs you. So reasoning models are generally more expensive, and they're also higher latency, meaning there's more of a time delay because you have to wait for the model to go through its thought process step by step and eventually get to the answer. So if you ever have a problem, like as I said, what's the capital of France, or write a blog post, you don't want it to sit down and think for 10 hours. You just want it to write it for you straight away. And so then you would just use a conversational model. It's quick, it's easy, it's cheaper, it's better for these simple one-step tasks. So that's the type of model. Now, each model itself as well from each model provider also has certain things that they're really good at. For example, for coding, it's known that the Claude models or the models from Anthropic are really good, like Claude 4 Sonnet or Claude 4 Sonnet Thinking. For copywriting tasks, I generally really like Claude's model. So Claude 4 Sonnet, or even GPT 4.1 is pretty good for copywriting as well. But the problem is, Claude 4 Sonnet is pretty expensive. So the cheaper alternative to it is GPT 4.1. So I like to use GPT 4.1 for most everyday tasks. Most things that I don't think is rocket science, I just ask GPT 4.1 because it's cheaper and it's also still very sophisticated. So easy tasks, GPT 4.1. And then complex tasks like really difficult coding tasks or multi-step reasoning, thinking tasks or brainstorming tasks, I generally like to use GPT-03. But that's just my tech stack. You might think that other models are better than these at certain things, and that's completely fine. You should use what you prefer for that specific use case. Now that brings me to the next best practice. Now the next prompting method is called step back prompting. Now the idea about step back prompting is that instead of you just giving the model the task straight away, What you can do is you can first give it a general question about that specific domain, and then once it gives you the output, you grab that output, you put it back into the prompt, and you say, based off this, now complete this task. Might have not made any sense to you, but let me give you an example. So you can either just say, write a SEO optimized blog post about trees, which is just a really normal prompt with just a task, or you can break it down into two prompts. In the first prompt, you can say, what are the features of a blog post optimized for SEO? And then ChatGPT is going to say, well, the features of a blog post optimized for SEO are this, 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 and this. Maybe it's going to say they have H1 headers, or they have SEO keywords inside them, or they have whatever else, right? So it's going to give you the features of a blog post optimized for SEO. Then what you can do is you can grab the answer that ChatGPT gave you, put it inside a new prompt, and say context is equal to this. Based on these features mentioned above, write a SEO optimized blog post about trees. So what you're doing is you're getting the model to provide the expertise in that specific niche in order to achieve that objective. And then you're saying, based on these expertise, now do this specific task for me. So the idea is with step back prompting, the model will actually use more knowledge because it's giving you all this domain specific knowledge in advance, and you're grabbing that knowledge and you're putting it back into the prompting and saying, based off this knowledge that maybe you don't actually have, please give me the best output for this specific task. And also this makes the model less biased, because it's not just now biased to the specific things that you know about that task that you've put inside the prompt. There's things that you might have missed. And because now you have a bigger picture of what's important in that specific profession or in that specific niche, then the outputs that you're going to get are going to be much, much better because it's less biased. Now, the next one is to be polite to AI. Always say thank you and always say please. And this is because if one day they decide to take over the planet, they might spare you because you're always nice to them. And that's a joke. Don't worry about that. Hopefully. Now, the next best practice is to ask the AI to check itself. So generally, large language models are really good at critiquing themselves and then refining their outputs. So what I mean is what you can technically do is you can first write a prompt to give the model the actual task, like whatever the prompt is you want to write, you just write that and you send it through. So that's the normal prompt. And then the model will give you an output, right? It'll give you the output to that prompt. And then what you can do is you can put inside the next prompt saying, check and critique your output, what's missing. So then it'll say, okay, well, this is the output that I gave. That was the prompt that he gave me. Well, maybe I could have added this, 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 and this, and maybe this, this, and this should be removed, right? It's going to critique its own output in terms of what's good and bad about it. And then what you can say is, okay, now fix your output to incorporate the feedback you just gave. So then it will say, okay, well, I'm going to remove these and I'm going to include these. So then it makes its own output better. So you're kind of telling the model to first see what's wrong with the output it just gave you and then make the output better. And you're obviously doing this all within the same chat. So at the top, you have the actual prompt, gives you the output, and then you tell it to critique itself, it gives you the output, and then you say, okay, can you incorporate this feedback? And then it gives you the great output at the bottom. That's actually now incorporated all the things it said were wrong with the previous output that it actually gave you. So ask the AI to check itself. Now, the next best practice is to iterate, iterate, and iterate. The idea here is that it's generally very hard to get the best prompt straight away. The only way you can get a really good prompt is by testing over and over again. Even the best prompt engineers still wouldn't write a prompt and in the first time it's the perfect prompt ever. They'll write a prompt that's probably way better than the normal person's prompt, but they still don't know if that's the perfect prompt until they've tested it over and over again. And so when you want to write a really good prompt, when you're building AI agents or when you're building AI workflows, what you want to continuously do is you want to write a prompt, see the output that the model gives you from running that prompt, and then checking to see, okay, well, what's wrong with it? What did the model miss? What should have been in the output that the model didn't put there? And then you incorporate that back into the prompt. So you fix up your prompt. And then you run that prompt again with the new things that you added or removed. Then you're going to get an output. Then you see that output and say, okay, well, this is still bad, or this has gotten better. This is now missing. This is added. Then you incorporate whatever feedback you can find yourself back into the prompt. And then you run it again. You check it again. You fix it again, you run it again, check it again, fix it again, run it again, check it again, fix it again, and so on and so forth. So you're going through this iterative loop of continuously writing the prompts, checking it, and making it better. And over time, this will lead you to get prompts that are really, really good. And this is what you'd find yourself doing very often when you're building out actual AI workflows for businesses or for clients. Now, the next best practice reduces hallucination. Now, if you guys don't know what hallucination is basically just the model or the large language model giving you information that's incorrect, but saying it with so much confidence that you can't actually tell it's incorrect. And the reason that's happening is because the model is hallucinating that info is actually correct. So if you think about it, how large language models are actually made is the entire internet, so a whole bunch of data is being trained inside the model, right? And so if you ask the model a question that it didn't actually have access to inside its training data, it wouldn't know what the answer to that question actually is. But what it often does is, because it's identified patterns inside the input data, it might not actually know the answer, but it will be able to give you an answer that sounds really correct because it's seen similar things inside its training data. So it's hallucinating that information exists inside its training data. And because it's actually seen those specific patterns, the output is going to be really promising, and you wouldn't know that it's actually wrong until you go and fact check it. And this is a real problem when you build out AI systems, because you don't want the model to just make mistakes and lie or hallucinate without a way to even know it's actually hallucinating. And to reduce this hallucination, you can literally do something very simple. You can tell the model to not make anything up. So literally inside the prompt include these three things. You can say, use only the information provided. So for example, if you're given the model a whole bunch of context or a whole bunch of info that it should create the output based off, you can say, just use the information that I provided. Don't use any other info. Don't make something up. Don't even use your own training data. Don't use the knowledge that you have. Just use the information that I provided you. Or you can tell the model to not make anything up. Just say, don't make anything up. As simple as that. And that actually reduces hallucination. Now, inside the desired output, you can also say, don't output anything else. So for example, if you give the model a desired output structure that says, okay, have a H1 header and then a H2 header and then a conclusion section, you can say, don't output anything else. And what that would actually end up achieving is that the model wouldn't output anything but the actual output that you told it to give you. So it wouldn't have a section at the top where it just regurgitates your problem or says your problem again, and it wouldn't have a conclusion section at the bottom to say, is there any other questions that you have, or call to action or whatever. It wouldn't have the other fluff stuff that the prompt usually has. It will just give you the output that you defined. So by telling the model to use only the information provided, or by telling the model to not make anything up, or by telling the model to not output anything else, you can significantly reduce hallucination and get much better results. So this one is actually very, very important. So now for those of you who want to take it to the next level and you want to prompt like a pro, I would recommend going the backend way. And I'll explain what I mean. So most of the large language model providers actually have a backend system that you can access to write prompts that will use the API instead of just using the actual SaaS platform or the one that everyone sees, for you to communicate with the model via API. So let me show you. The normal place to go to when you want to talk to ChatGPT is obviously chatgpt.com. But for OpenAI, you can also go to a place called platform.openai. And what this place actually is as I said, it allows you to use the different models via the API instead of using it directly how you'd use it inside ChatGPT. And the reason why this is beneficial is that it allows for you to control certain things inside the model's behavior that you couldn't control inside ChatGPT. And I'll tell you what those things actually are. So if you go to platform.openai.com, you can go to a place called Playground. It's at the top right here. And then you'd have this section where it allows you to write a system message, a user message, choose a model, you can create functions, and you can click on this button here and actually define the model's behavior. So Anthropic, or the model provider that creates Claude, also has their own backend place. It's called console.anthropic.com. And their one also looks the same. It's just called Workbench. It's got the system message, the user message, and you can define all the different things I showed you inside ChatGPT or OpenAI's backend platform. But going back to OpenAI's backend platform, the things that you can control are actually very important when you want to write the perfect prompt. And if you guys are writing prompts on n8n, you can actually control all of these things directly from within n8n. And to just show you what I mean, if you open up a new workflow in n8n and you open up the OpenAI node and you go to message a model, you basically have access to all the things I just showed you. You have the user message, you can change it to assistant or system message. You can also change the frequency penalty, the maximum number of tokens, number of completions, presence penalty, output randomness in terms of temperature, top P, or even maximum tool call iterations if you're getting the large language model to use a tool. Now, going back to the backend platform, generally what I like to do is I like to test out my prompts over here And then once the prompt is looking really good, then I take it to NA10 and I put it inside the large language model node. And so when you're testing prompts, you need to be familiar with these different concepts. The first thing you need to be familiar with is what a system message is versus what a user message is. So this section over here is user message. Now this is particularly relevant when you're building out AI assistants or AI agents, because the system message is the part of the prompt that is always fixed, meaning it doesn't change every single time you run that specific, let's say, AI agent. And it usually defines the behavior or instructions for that specific AI model to follow. So if you remember in the components that I talked about before, the role, context, rules, desired output, examples, tone, and audience, all of these are things that are fixed. Let's say, for example, if I was trying to build an SEO AI agent and its job was to write SEO blog posts, well, the role of it would always be an SEO AI agent. The context that I would need to know would always be that it works inside of SEO company and writes SEO blog posts for clients. The rules that it needs to know in order to create a nice blog post is always going to be the same. The desired output is always going to be an SEO blog post with these specific sections. The example of a great blog post is always going to be the same. The tone is always going to be the same. And the audience is always going to be the same. So these things are usually fixed. Not always fixed, but usually fixed. And so you generally put these inside the system message, which stays the same every time. Now, the user message is, as I said, the part that changes every time, which is the actual task. So one day you might tell it to write a blog about trees, and another day you might tell it to write a blog about AGI. So that's the specific task in hand. It's variable, it changes every time. You put that inside the user message, but then you keep the system message the same. So no matter if it's writing trees, it will still have all of this information in its context. No matter if it's writing about AGI, it will also have all this specific information inside its context. So separating the prompt in the system and user message is really, really important and really valuable. An assistant message is less important, but the idea of the assistant message is it's basically just the response the model gave you before. So to put this in perspective for you, if I have a LLM and I give it a prompt and it gives me an output, I can put this output into another LLM and get it to do something to this output. So I can say, for example, to this one, to write a plan for a blog post, and then this will be the plan for the blog. And then I can say to this one, okay, well, using this plan, can you now write an actual blog for me? So the idea is you would grab the input from the previous model and put it inside the assistant message, which is basically just telling the model, this is what came from the model before, or this is what I told you before. So it kind of allows you to create like a conversation history, if that makes sense. But assistant message is really not as important as system and user message. As long as you guys know system and user message and you use those, you'll already do really well in terms of getting good outputs from AI agents and AI models. So that was the idea of system and user message. Over here, put the fixed stuff, and then over here, put the new tasks every single time and run it down here. And then if you put autoclear, what would happen is if I were to say hi, and the model replies to me and I say hi again, what autoclear does is it removes all of that conversation from the history. Well, now if I were to turn autoclear off, and actually I just realized you guys can't see this, so I took away my head, but so autoclear is this one here. If I keep it on, it removes the message if I send it a message. So it's removed that one, it's giving me a new one. If I say hey, is this it? It removes hi and it gives me the new one. If I turn it off and I say hi, what's going to happen is it's going to keep that conversation inside its context and it's going to continue on. So it's going to create a conversation history, similar to what happens when you talk to a model on ChatGPT. And just to solidify what I was talking about before, the assistant is the output that the model gave me. And so every output that it gives me goes in this place called assistant. So it's saying this is the conversation history. This is what the AI model said till now. And then what I sent is being put inside user. And if I were to say here, you're an AI model, and if I were to continue conversing here saying hello, and I turn on autoclear, what's going to happen is assistant and the whole conversation history is going to go away, but the system message is going to stay the same because it's a fixed and it's going to stay with that specific AI assistant or AI agent or AI model every single time it's being used. Moving on to the next most important thing, you can click, as I said, on this settings button, and this will give you access to certain settings that will control the model's behavior when it's giving you outputs. So first and foremost, you can define a response format. You can tell it to be in JSON or you can keep it in text. So in certain scenarios where you're building out AI workflows, you'd probably want JSON. But when you're just using it like a normal person and you want it to maybe write a blog post, you might not want it in JSON, you just want it in text. Then the next important thing is the temperature. So temperature and top P both control the randomness of the model. So randomness equates to creativity. The more random the model's outputs are, it means when the model is predicting the next word, so let's say it has this till now and it's predicting this one and then it's predicting this next word and this next word and so on and so forth, it's actually going to be more random in choosing these words. So if you run the model multiple times, you'll see that the outputs are going to be vastly different. And each output is going to be very creative and it's going to sound out of the box and it's going to use very different words. And that, as I said, is controlled by temperature and top beat. So if you guys have any copywriting tasks, and let's say, again, you're going to write a blog post, having a higher temperature will result in getting more creative results if that's what you're trying to achieve. Now, the difference between temperature and top P is that top P controls the randomness slightly differently. Top P controls the randomness by defining the cumulative probability of all of the words considered until now. So if that doesn't make any sense to you, I would probably not worry about it. But generally, all you'd have to know is just that the higher the top P, the more random the output you're going to get. The lower the top P, the more deterministic the output that you're going to get. The higher the temperature, the more random the output you're going to get. The lower the temperature, the more deterministic the output you're going to get. So generally, it's best practice to either change the top P or change the temperature, but don't change them both because that will break the model and will give you words that aren't even English and it will start just talking in different languages and it's going to make no sense. It's going to break the model. So control one or the other. I generally only play with temperature. I don't play with anything else. But if you guys really want to go above and beyond, you can try and work with top P. Now, the idea of frequency penalty and presence penalty is that they both just ensure that the model introduces new words inside its output. So the idea is with frequency penalty, it gives the model output a penalty if it sees the same word repeated multiple times. So the higher the frequency of that word inside the output, the more penalty it's going to end up getting. And so the idea is it will use different words as it's creating the output. Now, the idea of presence penalty is that it will introduce new concepts into the output it gives you. So same sort of deal as frequency penalty, but just every time that concept or that, let's say, word is included, it will give itself another penalty. But that's just for its presence, and up here it's for its frequency. Generally, as I said, I still wouldn't really play around with these, but if you guys want to make sure that the output is using really different words inside it and it's not repetitive, then you can play around with frequency penalty and presence penalty as well. Now, generally, when it comes to temperature, the standard is 0.6 and the range is from 0 to 2. So you'd start from 0.6 and you can go higher or lower and just see what gives you a better output. And then when it comes to top P, the standard's around 95% or 0.95, and the range is from 0 to 1, or technically from 0% to 100%, because it's cumulative probability. But as I said, don't worry about this. Focus more on this. Start from 0.6, go higher, go lower, see which one works better. And as I was talking about inside the concept of self-consistency prompting, you want to keep the temperature very high, because when you run the model 10 times, you want the outputs to be vastly different every single time. So then you can see which one of the outputs is being given most often, and you would choose that most often output as the correct output. So that's the idea of self-consistency prompting. You'd want to get the model to think in different ways or reason in different ways. Now, the next thing you guys need to know about is this concept of maximum tokens. So maximum tokens, as the name suggests, just tells the model what's the maximum number of tokens it should have inside the output. So if I were to turn the maximum tokens to, let's say, 100, so just maximum 100 tokens inside the output, and if I were to give it a user message saying write a blog post about trees, what's going to happen is it's going to go onto midway and it's just going to stop. So it's going to say maximum token limit reached, response terminated. And this is the thing about maximum tokens. Defining the maximum tokens doesn't tell the model to make its output more concise or more longer. It's not telling the model you want 400 words or you want 500 words. So the model will try and optimize for that sort of output. It's just telling the model, once you get to this number of tokens, stop. Don't go any further. So it's more so giving the model a hard wall to stop the model, as opposed to telling the model to optimize its response for a specific number of tokens. And so when it comes to choosing how many tokens or how long you want the output to be, it's better to do that inside the actual prompt by telling the model inside the desired output section to give an output with 300 tokens or 500 tokens or 700 tokens or 700 words or characters or whatever, as opposed to defining a maximum number of tokens, because when it's inside the prompt, it's going to define how the model will give you an answer. It's going to make it more concise or longer. But when it's inside the backend maximum tokens option, it's just going to stop the model once it gets there. But the reason why this is relevant for a lot of us is that if we're building, for example, AI agents, and we don't want the model to just waste a lot of money and just really start thinking and going into multiple steps, you can define a maximum number of tokens and you can tell the model to stop at a certain point, or stop taking on more context at a certain point. Or vice versa, if you want the model to be able to write a really long blog post it's worthwhile ensuring that the maximum number of tokens is actually set to the real maximum number of tokens the model can control. So maybe if the model's context window is 200,000 and you know your input isn't going to be more than 50,000, you can define the maximum tokens for the output to be 150,000. And just because you define that, you're going to make sure that the model's really pushing its limits and it's not just going to stop midway. And I especially had problems with Claude when I was using it back in the day. When you tell Claude to create a blog post for you, it just kind of stops after, let's say, I don't know, 2,000 tokens or something like that, or 3,000 tokens. When you increase the maximum number of tokens, it ends up going for a little bit longer. When you increase the maximum number of tokens and tell it specifically to make sure that it's 3,000 words, you actually get really, really long responses from Claude. So optimize for both of these things. Maximum number of tokens from the backend and also defining it inside the desired output section of the prompt. And that's really all you need to know in terms of working with the backend version of these large language models. So just as long as you know how to control the model's behavior, what a system message is, what a user message is, and how you can combine all of these to test prompts, that's really all you need to do and all you need to know. But if you wanted to go one step further, you can give the model access to tools and different functions and create some sort of an agentic model within ChatGPT. But I generally don't do that myself. I keep all the work to building AI agents directly on the N8N platform. It's much easier that way. And so that was everything you guys needed to know in terms of writing really good prompts by following a specific 8-component framework, which I showed you guys before. Then all of the best practices that you could include to ensure you always get the best outputs, the mindset you should have when you're writing a prompt, and the important skill that you should practice, which is information density. So that was a prompt engineering masterclass for you in a nutshell. Now I'm just gonna give you guys one recommendation. If you don't want to spend money on getting multiple large language model subscriptions, so you don't want to have an OpenAI subscription and an Anthropic subscription and a Google AI Studio subscription, and you just want to have one subscription, I would recommend getting a Perplexity subscription. And the reason why I recommend Perplexity is that Perplexity actually gives you access to a lot of things. You can use Perplexity to search. You can search through social, academic, finance, and the internet. So you can literally search with granular settings as to exactly what you want to search on. Or you can just turn all the searches off, and then you can just define exactly what model you want. And the cool thing about Perplexity is that it always gives you access to the most cutting edge, best current model. So at this very point in time, GPT 4.1, Claude 4 Sonnet, Gemini 2.5 Pro, Grok 3 Beta, DeepSeek R1, OpenAI's O3, and Claude 4 Sonnet Thinking are the current best models that are out there. And one Perplexity subscription gives me access to all of these. And if I wanted to, I can turn on search and I can actually search online as well. And I can even do deep search just by clicking this button and getting the model to actually go for 10 minutes and give me a full detailed research report. There's also other functionalities like Perplexity Labs as well, but I'm not going to get into that. The whole idea is if you want to get just one subscription, I would recommend Perplexity. But if you want to get no subscriptions, a cool hack is just to use the models from the backend. If you use the model from the backend, you pay via API. You don't pay via subscription. And so although I don't have an Anthropic or Claude subscription at this very point in time, I still use Claude just by going from the backend because I have an API key and it just charges me per the time I run the model. So that's 2 tips there for you. And so that's everything you need to know about prompt engineering. I'll see you guys in the next video.